If you've been working with Azure Data Engineering for years, you know that the platform has evolved from traditional PaaS solutions to Microsoft Fabric, a unified data and analytics SaaS platform that's now a strong competitor to Databricks. With this shift, Microsoft is retiring the Azure Data Engineer certification and replacing it with the Fabric Data Engineer Cert, which requires passing exam DP700. So whether you're an experienced Azure data engineer or new to Fabric, preparing for DP700 means mastering Fabric's data architecture, CI/CD and ELT pipeline design, real-time streaming workloads using Spark structured streaming and KQL event streams, and advanced performance tuning with Spark, KQL, PySpark, and SQL. You'll also need solid skills in Fabric administration, security, and governance, similar to DP600, but with a deeper focus on data engineering rather than reporting or semantic modeling. In this video, I'll share 5 practical tips to help you get ready for the DP700 exam and earn your Microsoft certified Fabric Data Engineer Associate certification. So let's dive in. Let's take a quick look at Fabric's data engineering architecture so you know how data flows and is organized in the platform. At its core is OneLake, a single integrated storage environment that all analytics engines use. This means you don't have to move or copy data across different systems. Everything stays in one place. Within OneLake, data is organized into domains, logical containers that align with business areas or data zones and help enforce governance and security policies. Inside each domain, you'll find workspaces, which are collaborative environments where teams create, manage, and share data products with their own compute and storage. The data itself flows from various sources, both batch and streaming, into the medallion storage layers, bronze, silver, and gold. As data moves through these layers, it's processed and transformed, improving quality, readability, and making it easier to analyze. To work effectively in Fabric, it's key to understand when to use the right tool for each scenario, such as event streams, event houses, Spark notebooks, pipelines, data flows, shortcuts, and mirroring. Make sure to study Microsoft's decision guides on choosing data stores and processing activities, so you can select the best approach for tasks like real-time streaming, batch processing, or advanced transformations. This foundational knowledge is essential for building reliable and scalable data engineering pipelines in Fabric. Let's talk about the medallion architecture in Microsoft Fabric. It's a best practice way to organize and refine your data as it moves through the platform. It all starts with the bronze layer. This is your raw data landing zone. You ingest data here with minimal transformation, keeping it as close as possible to its original state. The key advantage is that you preserve the source data along with metadata, which helps with lineage tracking and auditing down the line. Next is the silver layer. Here, the data is cleansed and validated. You apply necessary business rules, convert data types, and structure relationships, basically preparing the data to be efficiently queried and used by downstream processes. Finally, you have the gold layer. This is your business-ready aggregated dataset. The data here is optimized for reporting and analytics and is shaped into data domain-specific models for your end users. This layered approach improves reliability, maintains data quality, and makes it much easier to serve trusted insights and analytics to the business. When designing ELT pipelines in Microsoft Fabric, modularity and flexibility are key to building scalable and maintainable workflows. Start with parameterization. Use parameters with string interpolation to make your pipelines adaptable to different datasets without rewriting code. This boosts reusability and efficiency. Master core pipeline activities like copy data, get metadata, lookup, and for each. These allow you to create dynamic ETL workflows that can handle diverse processing logic. Define your pipelines as DAGs, or directed acrylic graphs, using JSON. This gives you precise control over execution order and dependencies, ensuring your workflows run smoothly. Avoid hard-coding dataset paths, creating separate pipelines for each dataset, or relying only on default parameter values. These practices reduce flexibility and make maintenance much harder. On top of that, leverage CI/CD practices for your data projects. Selective deployment is essential when promoting specific content from testing to production. This provides precision and avoids impacting the entire environment. Well-designed deployment pipelines enable organized content promotion while automatically flagging invalid references, improving reliability and governance. By combining modular pipeline design with robust CI/CD processes, you build data engineering workflows that are both adaptable and production ready. To optimize Spark performance in Microsoft Fabric, start by choosing the right Spark Compute options based on your workload needs. Use custom Spark pools for high-demand, resource-intense jobs that require dedicated power, while starter pools are great for lightweight and rapid prototyping. Leverage consistent environments to manage package dependencies effectively, and enable high concurrency mode to maximize resource usage when running multiple tasks simultaneously. For performance optimization, take advantage of autoscaling, which dynamically adjusts compute nodes based on workload demands, ensuring efficient resource use. Utilize intelligent caching, which is enabled by default to speed up repeated data access. Implement V-ordering, a technique that optimizes read operations for better performance. Use materialized views to store pre-aggregated datasets, reducing query time. Regularly perform Delta Lake maintenance commands such as optimize and vacuum to improve storage and query efficiency. By aligning your Spark configuration with these best practices, you can achieve faster, more efficient data processing that scales with your demands, delivering faster insights and reducing costs. To get the best performance from your queries in Microsoft Fabric, you need to optimize across different languages and tools. For KQL, leverage materialized views for workloads that repeatedly access the same data patterns. Also, always limit the query's time range using datetime filters to reduce the volume of data scanned and speed up results. In SQL, use column store indexes to accelerate analytical queries and carefully choose the join strategies based on the relative size of your tables to minimize processing overhead. When working with PySpark, partition your data appropriately to parallelize processing effectively. Use broadcast joins when joining small tables to avoid expensive shuffles, and cache frequently accessed data frames to speed up iterative operations. For external file-based data, keep file sizes at least 4 megabytes for efficiency and split large compressed CSV files into multiple chunks to optimize read and write throughput. Applying these targeted optimizations helps you reduce resource consumption, improve query responsiveness, and support larger scale analytics workloads. Microsoft Fabric offers powerful real-time analytics and streaming capabilities that enable you to process and analyze data as it flows in, delivering timely insights. A key concept is windowing, which controls how data is grouped over time to enable accurate analysis. Tumbling windows are fixed size, non-overlapping intervals that partition data without gaps or overlaps, providing a clean, segmented view. Hopping windows are fixed size but can overlap, giving smoother transitions between time periods for continuous insights. Sliding windows move continuously forward, including only events with a set duration from the current moment, ideal for real-time trending. Session windows open dynamically based on incoming events and close after a specified period of inactivity, capturing user sessions or even bursts naturally. Also, when working with Event House and Fabric, if you don't configure minimum consumption, the system will automatically suspend during idle times to save costs. But this causes delays when reactivating. Enabling minimum consumption keeps resources running at a minimal level for continuous availability and faster responsiveness. Mastering these real-time concepts allows you to unlock the full power of Microsoft Fabric's streaming platform for building responsive, event-driven analytics solutions. Mastering security and governance in Microsoft Fabric is essential for protecting your data and ensuring compliance. Start with authentication methods. Fabric supports several options. Service principals for automated processes and applications providing secure, non-interactive access. Managed identity allows Azure resources to automatically manage credentials without manual secrets. OAuth enables user delegation with temporary access tokens, perfect for interactive user scenarios. SQL authentication remains available for legacy systems requiring usernames and passwords. On the data protection front, Fabric provides robust controls. Column-level security automatically adapts to schema changes, restricting access to sensitive columns. Row-level security applies to all users, including admins, enforcing fine-grained data access policies. Data masking hides sensitive information while keeping data usable for analytics. Always be mindful of row-level security risks, particularly inference risks and attacks, when cleverly crafted queries might expose sensitive data through error messages. Proper governance involves anticipating these risks and implementing safeguards. By understanding these authentication options in great detail and data protection mechanisms, you can build a secure, compliant Fabric environment that safeguards valuable data without compromising usability. To maximize your chances of passing the DP700 exam, start by taking the official Microsoft Learn Practice Exam until you've consistently scored a 90% or higher. Complement your studies by watching the comprehensive 6-hour DP700 training course by Will Needham, and check out extra content from creators like Aleksi Partanen, PorcuBI, and Microsoft Reactor. Just as important, get hands-on. Practice building production-ready data pipelines using the Medallion architecture. This real-world experience will reinforce your understanding of Fabric's capabilities and best practices. Master these areas, and you'll set yourself up for success on the DP700 and take a big step to becoming a Microsoft Certified Fabric Data Engineer Associate. I'll go ahead and leave helpful links in the video description to guide your prep. Good luck.